So this is the start of Lab2 setup. I'm on my AWS. I have an instance that I've created called Vios Lab2, and you can see under the network settings I've associated with the Elastic IP address. You can see that down on the left here. If I go over, this is my Elastic IP address, so we know that it's been allocated to my account and associated with this instance. So then if I go and ping the corresponding Elastic IP address, I'm getting a response. Now I am going to SSH in. So using the command found in one of the help pages on Amazon, it's SSH, the security settings are all set up. So it's SSH -I, the file with the public or my private key, lab2 pem, the instance name that can reference by Vios, and then the IP address, which is the one that I just pinged. And so here I am logged into, remotely logged into the virtual machine on the AWS server. Here I'm creating the second instance for the client. And so I set up the VPC for it. I associated the subnet with the network one router. And I'm going to add this. I want to connect it to that. Figure with the same security that I had before. Choose the same private key. And now it's launched. Now I have also configured my two other VMs, which I've named client and server. And so for each of these, I set up two network interfaces. The primary network one on ETH0 is what I allocated or associated the Elastic IP address with. And you can see for both of these, the primary network one, ETH0, has a public IP address associated with it. So now I'm going to SSH into both of these. So right here below, you can see that this is for the client and 44.236.34.212. So using my private key, I'm going to SSH in, and I'm in. And then likewise for the server, just so you can see, it's 54.185.104.110. So I'm going to do the same private key, associate all the security the same across all my VMs, so we can use the same private key. And I'm logged into that one as well. So all the VMs are currently working.
These are the configured VMs on AWS on our VPC that we created. So this is the Vios router. So we can see that we have ETH0, ETH1 set up, ETH1 corresponding to the subnet for our local network, and then ETH0, which is connected to the internet gateway. So if we go into config and then we show this, is that we set an address for the internal network on ETH1, so that's going to be listening for any requests from our client and server. And then we can also show service. And now we just created a subnet. It's the default router. This is the one that we set up on ETH1. It's also the DNS server. So it allocates these address ranges. So that's the setup for the Vios. And then if we go in, this is our client. And what we did was we configured in the routing table after we got all of the network interfaces up and running. We configured for this default destination, which is on the subnet, the internal network 10.0.2. With this mask, we set the gateway to be the BIOS router, and that's going on ETH1. And so likewise, this is for the server. If we go if config, this is same deal. We got that set up, and then we do the route, and likewise we did the same thing with the gateway. So now, if we do, we're going to go enter in to the bash script here so we can actually type commands in, and we're going to go TCP dump -I, and we're going to listen in on the router itself. So that's the IP address of the router on the internal network. And that didn't work. What did I type before? Okay. So you don't actually type in the address. It's TCP dump -I, and then we're listening on ETH1, which is the one that's configured to the gateway for the router. And so listening on that, it's waiting for responses. So then from the server, if we ping the address of our client, which is 10.0.2.35, which is on that subnet, when we start pinging, you can see that we're getting replies, and so this only is listening in on the actual router from the router IP address, so we know that this is going through and actually contacting via the BIOS router. Okay, so now we're going to do the iperf to see how the network's actually performing. So this is on the server, iperf3s, so we're listening on this port. And then from the client, we're going to go with using the port 5201 -U to signify UDP, and that's the IP address of the server. And for bandwidth, we played around a little bit, so we're going to go with the maximum bandwidth that we can get, and so we're going to go with 1 gig. So this is what it is currently for UDP right now over the link. So you can see that we're getting pretty high bandwidth, almost 600 megabits per second. And then we're going to do the same thing, but we're going to take off the -U to signify TCP. And so now if we do the same, so we can see at the bottom that the bandwidth is significantly less, just about half of what the UDP is. Additionally, we can see that there's retries 96, so that has to do with, or that will reduce a lot of the bandwidth as well. So largely the reason is the TCP overhead along with these retransmissions that are causing a lot of the bandwidth reduction. And now we change, you can see on the bottom for both the client and the server, we change these configuration aspects. So exit out, and then going to listen again. So we'll start again with the UDP. And so we're getting a much higher bandwidth now for the UDP, almost a gigabit per second. And if we do the same thing now again for TCP, we're getting a much smaller bandwidth for TCP. So the network parameter that we changed had to do with the delay of sending the packets or actually transmitting the packets. So there's a queue that builds up information for UDP or for TCP that's designated for a certain network interface. So for UDP, since it's best effort, a lot of those packets are being dropped because that queue is going to overflow with a 100 millisecond delay on it. And likewise for TCP, since it's a more of a guaranteed service in terms of the information it's delivering, the bandwidth is reduced, but the ultimate retransmissions it's not occurring because of the delay. So now we're going to change the configurations again. You can see we changed it for the server. And the same thing, we're going to change it for for the client, and now we're changing it for the server. And so now if we run iPerf3 again, we'll run it UDP first. Let's try it again. Okay, didn't work first time, but here we go. This is for UDP. And so similarly, we're getting relatively same bandwidth, but fewer lost datagrams. And now if we do it for TCP, yeah, so there's much more retransmissions because since there's a loss percentage involved, you're going to have to frequently resend transmissions over TCP. You can also see that in the window size that it frequently reduces to pretty small because of those, the 10% loss. Okay, so now we deleted the old QDIS configuration, and we're going to set up this new one on both client and server. And so then we're going to run the same commands as before. So we got it up on the server. We're going to run it UDP first. Okay, which is nearly it's looking like 100% loss. And now we're going to do it for TCP. So now I changed the configuration on Vios right here, sudo qdis. So I added a delay for it, and then this was the initial output for the UDP, and now we're going to do it again for the TCP. So now I just reconfigured it again to change the delay to 0 seconds, but add in a network loss of 10%. So we're going to go ahead with the UDP to start. Relatively similar, and then we're also going to do the TCP. Yeah, which as expected has a lower bandwidth because of the loss percentage. So now I've just deleted the current configuration and added a new one with the 100 megabit latency, or yeah, the rate of 100 megabits and a latency of 1 millisecond. And I'm going to perform the last few tests. So this is for UDP. And then TCP.